Okay, so we have this system of equations, and nothing matches up. We don't have common coefficients, and we don't have opposite coefficients. So what we need to do is we need to look at it and see, what could I multiply one of the the goal is to only multiply one. What can I multiply one of these equations by in order to be able to have a common or an opposite coefficient?
Multiply the x by 2.
Okay.
Negative 2.
-2. I was about to ask if anybody had any better ideas. That's good. Yes, let's do that. Let's multiply this whole equation. We're going to multiply everything by -2. The reason we do that is because it's going to create opposite coefficients, and they're going to cancel out without us having to subtract.
I really don't like that. Well, that's too bad, isn't it? And then do you have to do, like,
What is that little thing on the end? That's stylus.
I don't know, it's just the way it's made. It's supposed to protect it. I guess keep me from breaking it. Okay, so now I'm going to distribute -2 to everything. So my new equation will be -2x
plus -6y equals -12.
Very good. Okay, and I'm going to add that to my equation that I have here, plus -7y equals -1. Okay. Oh, by the way, I did KCO over here. Okay, so when I add those cancel out and give me 0. These add up to give me what? -13y. And -13. Can divide, but -13 on both sides, because I showed that step, unlike some of you. And that gives me y equals 1.
sorry, on my home I didn't have enough room.
And we got
Okay, so now we have to plug in. You can plug in to, well, hold that thought. I would plug into the original equation. That way, cuts down on error. And so you can plug it into this equation if you'd like, or this one, either one. They're really, neither one is any harder than the other. Any preference here?
The top one.
Top one. Okay, fair enough. All right, so we have x plus 3 times 1 equals 6.
one of us is going to be x plus 3 equals 6. Back to both sides, x equals 3.
Yep,
3, 1.
that is correct. So our answer here is 3, 1. Okay, so actually you can solve a lot of problems with multiplication. Yes, it's an extra step, but you can also fix a lot of things that might not work out. Just so. Okay, let's look at number, let's go ahead and just jump right in there and look at number 10. Okay. This has it all. We'll have to rearrange.
Great.
Well, yeah, no, you have to have your equal signs lined up. Equal signs have to be lined up.
I feel personally attacked by William.
Okay, so,
Subtract 4.
yes. All right, let's start with the rearranging of this equation right here. Whoa. Sometimes there's a toolbar. I don't even think y'all can see that. No, it doesn't show up. I actually accidentally hit a toolbar and it catches me by surprise every time. All right, so let's rearrange. We have 2x equals 4y plus 18. And I'm going to show my steps and do the algebra here so that I get it right. Subtract 4y from both sides. So what is this new and improved equation?
2x minus 4y equals 18.
Okay. All right, so yay, that is done. That's a nice color. So now I'm going to line everything up. 2x minus 4y equals 18. Lines up with negative 5x minus 6y equals 3. Okay. Yes. We are going to have to multiply both.
You multiply the top
We-
by 3 and the bottom by
I was
-2.
gonna go with -5 on the top. And then 2 and.
Okay, well, I would probably look at the the 4 and the 6. Yes, because I could, well, here, the 2 and the 5 would work. You would just have to multiply them by each other. But I see what William and Abby were going for was they wanted to turn the 4 and the 6 into 12, correct? Okay, so they looked at that and said, okay, so basically this is a game of least common multiple. And then you have to find what makes the least common multiple, which sounds an awful lot like least common denominator. Oh, there it is. Everybody loves to add and subtract fractions. But it's the same idea. It's just not, you're not in fraction form. Okay, so I can do it. Let's do it with the 12, and then Abby, I can go back and do it. Addie, I can go back and do it with the 10 if you want to. Okay. All right, so what do y'all want to multiply the top by? Okay, and the bottom? -2. Okay. All right, I'm going to put these in parentheses so that they don't look like they're just floating out in the middle of nowhere. All right. So the whole thing, all things in the equation multiply here, 2. Okay, so we're going to get 2 relatively, for the most part, brand new equations.
If you multiplied that one by -2, why would you multiply that by -2?
Because, and we're trying to make opposite coefficients. And they,
Why won't we just make common ones?
well, we can, but then you have to subtract and change signs again anyway. So it's up to you. You can do either way. All right, so what do I end up with on the top?
6x plus -12y
Equals 54.
Okay. And what do I end up on the bottom?
10x plus 12y equals -6.
Okay. So this is my new system. Clearly, I'm going to have to go to the next page. I'm out of room. Anybody? Can I move? Does everybody have that? Okay.
48. Is that it?
Mm-hmm.
Yeah.
48. Well, I might not. I might have room. Here. Going to add. And that would be 16x. Those cancel. Equals 48. I'm going to divide both sides by 16. And what do I get? X equals 3. Okay, now remember what I told you about plugging back into the original equation. So, which original equation would you like to... And by original, I mean the green ones up here. These.
That one, the top one.
The top one? Okay.
The top one.
All right, so I'm going to have 2x equals 4y plus 18. I'm going to plug in 3 for x. And get 6. Going to subtract 18 from both sides. I get -12 equals 4y. I'm running out of space. What do I get? Even though I'm running out of space, I still showed my step. And I get y is -3. There is absolutely not another piece of room. Oh, wait, maybe there is right here. So my solution is 3, -3. Right there in the middle. Okay. So, not as big a deal as we once imagined.